What's up? What's up? It's your man, Jimmy Chan. All right, so today we're talking about independence and the multiplication rule. Well, an event is independent if the occurrence of event E in a probability experiment does not affect the probability of event F. So that almost sounds like mutually exclusive, but it is not. It is not at all, okay? So mutually exclusive says that they have no outcomes in common, where independent says that one event doesn't affect the other event, okay? And dependent, obviously, that one probability, one event does affect another event, all right? So let's go ahead and take an example. And here in this example, I showed you guys what would be considered independent versus dependent. So suppose you flip a coin and roll a die. Well, flipping a head doesn't necessarily gonna say, oh, you're gonna roll an even number because you flipped a head, right? So that those two would be independent. Earning a bachelor's degree, chances are is because of that bachelor's degree that you will get $100,000 salary per year, right? So, and then if two 24-year-old male drivers in the United States happen to get in an accident, it doesn't necessarily mean that one caused the other, right? And that's what it means by being independent. Okie doke. All right. So, first of all, we have to compute at least one probabilities, right? So at least one is for one. At least one will occur. That means it's one minus that none will occur. All right. So let's compute the probability that at least one male out of 10, the age of 24 years, will die during the course of the year. If the probability that a randomly selected 24-year-old male survives a year is 0.9986. Okay, so to find the probability that at least one would die, that's the same as saying 1 minus the probability that none would die. Okay? This is the bigger piece right here, is how to write that out. Okay? And for a 24-year-old to survive, it is 0.998. Well, it's the same thing as not dying, right? So that means this is going to be 1 minus the probability of the first one survives times the probability of the second one survives times the probability of the third one survives, right? I'm sorry, not times ... the fourth one, the fifth one, the sixth one, the seventh one, the eighth one, the ninth one survives, and the probability of the 10th one survives as well. Now, why did I go all the way out to 10? It's because this does say 10 out of 24, so I had to do all 10 of them. So it's 1 minus all that. And for each one to survive was 0.9986. So I gotta multiply this 10 times, right? Because I have 10 of them. So that means I'll have to take this probability and raise it to the 10th power, or just multiply it 10 times, okay? And what you will get is approximately 0.014 as a probability of at least one of those 10 24-year-olds that will die that year. All right, so there it is. All right, so the next example. Multiplication rule for independent events. Okay, so notice that what we have here, right? If the event E and event F, then we would multiply. So again, because of and is why we're multiplying. Okay, so for example, in the game of roulette, the wheel has a slot of 0, 00, and 1 through 36. The metal ball rolls around the wheel while it falls into one of the number slots. That means to get each slot is a chance of 1 out of 38 because there's 0, 00, and then 36 other slots. So the first thing says the first question asks, what is the probability that the ball will land in the slot number 21 2 times in a row? Well, so in other words, we want the probability of getting 21 and then getting another 21. Well, if that's the case, that means I got 1 out of 38 chances on the first round. And I'm going to multiply by another 1 out of 38 chance, right? So, if that's the case, then I'm going to have 1 out of 1,444 chance of getting that to happen. Okay. Now, on the second one, B, it wants to know what's the probability that the ball will land in the slot number 21 4 times. So in other words, I want the probability of the first one being 21 and the second one being 21 and the third one being 21 and the fourth one being 21, right? So if that's the case, then it's going to be 1 out of 38 times 1 out of 38 times 1 out of 38 times 1 out of 38. Well, that's going to be 1 over a really, really, really big number, which is 2,085,136, which is quite the odds against you when it comes to that. Well, I hope this helps. If there's any questions, please let me know. See ya. Bye.